For over a year, scientists around the world were quietly tracking something most people never heard about. A building-sized asteroid with a real, rising chance of slamming into the moon, live in full view of Earth, on a specific date they could already calculate down to the minute. Some researchers were preparing observation timelines. Others were calculating what a flash visible from Hawaii might look like. This wasn't science fiction. This was a real, escalating probability, tracked by the most powerful telescope humanity has ever built. And then, just months ago, that probability collapsed to zero. This is the story of Asteroid 2024 YR4, and the year the world spent watching a threat that started with Earth, moved to the moon, and ended in one of the closest calls in the history of planetary defense. I'm your name, and this is your channel. If real space threats, and how close they actually come, are why you're here, subscribe now, because this story took some genuinely unexpected turns. It started on December 27th, 2024, at a telescope in Chile called ATLAS, part of a global early warning network built specifically to catch asteroids before they catch us by surprise. Astronomers spotted a new object, later named 2024 YR4, and ran the numbers on its orbit. The initial calculation gave it a small but real chance of striking Earth on December 22nd, 2032. Not huge, not zero either. Over the following weeks, as more observations came in and the asteroid's orbit got measured with greater precision, that number didn't shrink, it grew. By the end of January 2025, the impact probability had climbed high enough to earn 2024 YR4 a rating of 3 on the Torino scale, a scale astronomers use to communicate asteroid risk to the public, where anything above 0 means an object deserves genuine attention. A rating of 3 was, at the time, the second highest rating any real asteroid had ever received. It triggered an official notice from the International Asteroid Warning Network. By February 18th, the estimated chance of an Earth impact peaked at 3.1%, the highest impact probability ever recorded for an asteroid of its size. For a few weeks, 2024 YR4 was, statistically, the most dangerous confirmed asteroid in the history of modern tracking. Here's what made it genuinely worth worrying about, at least hypothetically. The asteroid is estimated to be somewhere between 53 and 67 meters wide, roughly the size of a 10-story building. That's not large enough to be a global extinction-level threat, but it's more than large enough to cause serious regional damage. Because of its stony composition, scientists expected that an impact over land would most likely produce an airburst, an explosion in the atmosphere rather than a ground crater, similar to, but potentially more powerful than, the 2013 Chelyabinsk event over Russia, capable of causing damage across a radius of roughly 50 kilometers. Naturally, this got attention fast. For the first time, the global planetary defense community had a real, credible, above 1% probability asteroid threat to coordinate around. Not a drill, not a simulation, an actual object with an actual calculated chance of hitting Earth on an actual date. Then, just as quickly as the threat had escalated, it started to fade, but with a twist nobody initially expected. As astronomers gathered more observational data throughout February and March 2025, including detailed imaging from the James Webb Space Telescope, they were able to substantially refine the asteroid's orbit. By late February, the numbers had shifted enough to essentially rule out any chance of an Earth impact in 2032. Relief, right on schedule. Except the story didn't end there. As scientists nailed down the asteroid's more precise trajectory, they discovered something else. While Earth was now safe, the moon wasn't necessarily. The same refined calculations that cleared Earth revealed a previously unnoticed possibility. 2024 YR4 might actually collide with the moon on that exact same date, December 22nd, 2032. And unlike the Earth impact story, this number didn't just appear and fade, it kept climbing. By April 2025, the odds of a lunar impact stood at around 3.8%. By June, new data pushed that number up to 4.3%. For months, every time scientists gathered fresh observations, the probability of the moon getting hit crept slightly higher, not lower. The opposite of what everyone expected after the Earth impact scare had been resolved. Scientists started seriously modeling what that scenario would actually look like. If 2024 YR4 struck the moon at its expected impact velocity of about 14 kilometers per second, the collision would release energy equivalent to roughly 6.5 million tons of TNT, about 400 times the energy of the Hiroshima bomb, carving out a fresh crater roughly a kilometer across. It would be, by a wide margin, the most energetic lunar impact ever recorded during the entire era of modern astronomical observation. Researchers calculated an 86% chance the impact would occur on the near side of the moon, the side facing Earth, meaning the resulting flash would likely be visible with the naked eye from parts of our planet, with Hawaii positioned for an especially good view, weather permitting. But the concern wasn't really about the moon itself. A lunar impact wouldn't meaningfully change the moon's orbit or pose any direct physical danger to Earth. The real concern was debris. Researchers began modeling the risk that a collision of this size could scatter a spray of small, fast-moving fragments, ejecta, into near-Earth space, potentially threatening the satellites we depend on every single day for navigation, communication, and countless other services. One NASA aerospace engineer noted this specific risk publicly, warning it could pose real hazards to Earth orbiting infrastructure, and even to any astronauts who might be operating on or near the moon at the time. For a while, scientists genuinely considered what could be done about it. A published, though not yet peer-reviewed analysis explored possible deflection strategies. The conclusion wasn't encouraging, with the asteroid's exact mass still uncertain, and not enough time remaining to send a reconnaissance mission to study it up close before any deflection attempt would need to launch. Researchers concluded that deflection missions appeared genuinely impractical given the constraints. For a stretch of time, the honest answer from the scientific community was that if the odds kept rising, there might not be much anyone could actually do about it. Then, in February 2026, everything changed again, for the last time. Astronomers Andy Rivkin and Julian DeWitt secured a narrow, difficult observation window using the James Webb Space Telescope, among the faintest, most technically demanding asteroid observations ever attempted, requiring a novel approach to using an instrument normally reserved for imaging distant stationary galaxies, rather than a comparatively fast-moving near-Earth object. They had only a couple of 5-hour windows in which the asteroid would be just barely bright enough and positioned correctly relative to the Sun to even attempt the observation. It worked. The new data allowed scientists to calculate the asteroid's future position with the greatest precision achieved yet, and the answer was clear. 2024 YR4 will not hit the moon. It will pass by at a distance of roughly 14,229 miles, about 22,900 kilometers, a genuinely close approach in cosmic terms, but a clean miss. NASA formally announced the result on March 5, 2026, ruling out the lunar impact entirely, closing out more than a year of steadily rising uncertainty with a definitive, data-backed answer. What's genuinely remarkable about this story isn't just the ending, it's the process. This was, in a very real sense, a live rehearsal for a scenario the entire planetary defense community has been preparing for, theoretically, for decades. A real asteroid, with a real trajectory, tracked continuously by multiple observatories, refined repeatedly as new data came in, with contingency plans actively discussed at the highest levels of the field, all resolved through nothing more dramatic than patient, careful, repeated observation. No last-minute rocket launch, no dramatic deflection mission, just telescopes, mathematics, and time. The asteroid isn't gone, and it isn't done being watched. It's currently too faint and too distant to observe at all, and won't swing back into view until 2028, when scientists will get another close look, refine its post-2032 trajectory even further, and continue monitoring it well beyond that. But for now, both Earth and the Moon are confirmed safe from 2024 YR4, closing out one of the most closely tracked near misses in the history of modern astronomy. If you want updates the next time this asteroid comes back into view in 2028, subscribe and turn on notifications, because we'll be covering it. Drop a comment with what you think. Should humanity be investing more in planetary defense before the next one isn't a near miss? And share this with someone who has no idea how close we actually came to watching a real asteroid strike the moon live from Earth.